recording. Okay. And my camera battery may run out in the middle. That's fine, I guess. Okay, so last time we learned about the motion diagram, and we also learned how to convert that motion diagram into graph and how to extract information from graph and the motion diagram. That's what we did last time. And then we also learned how to find change in velocity by using motion diagram or using two consecutive velocity, okay? And the method was to draw them side by side, okay? And then once we draw them side by their tail lined up, what we do next is that we draw another vector. So we draw lining them up tail to tail like this. And then we draw another vector by starting from the tip of the which vector? Previous to the later. So that's important, okay? Previous to the later. So if this previous is shorter and later is longer, then it's going to point in that direction, in the direction of these original vectors, okay? But if they are otherwise, when they are slowing down, it's going to be pointing other way around. So for example, B2 is shorter than B1, so that's why it gets flipped, because previous is the B1 here, okay? And then we did the polling on this, but we haven't done polling on this. So it's not just for the straight vectors, it could be the inclined vectors like this. The same rule, you line them up, by the tail, side by, by the tail. And if they are inclined, then you want to keep them inclined like that, okay? If they are inclined, you want to keep them inclined. Do not make them straight, okay? You cannot change the direction. You can just move that one, move one tail to the tail of another one, okay?
Sir, as a heads up, just so you know, your microphone dropped about half.
Oh.
Okay, just in case you need to know, your microphone dropped by about half in the last 10 seconds.
Okay.
Yeah, I noticed it.
Now better?
No.
No, sir.
Huh.
No.
So let me.
Did you put something over your microphone, sir?
Nope, I did not. It's right there. Can you hear me now?
Yes, sir.
Yes.
Okay. How about now?
That's okay. One more time.
How about now?
That's fine. Yeah.
Okay, great. Okay, so
You're still kind of quiet to me.
oh, so let me do one thing here. So let me turn off the microphone.
Oh, that's better. Say something. It seems like it fixed itself.
I believe he's messing with the microphone settings currently.
Right, so I just turn this off briefly and turn back on. So does it sound better?
Yes, sir.
Okay, great. Thank you for the feedback, okay? So now, what I was saying is, you cannot change the direction. You need to move way it is, but you can move it without changing direction and line up the tail to tail, okay? That method is still valid. We talked about no matter how they are, okay? So you can use the same method. So go ahead and draw it and answer it. So I'm giving you 2 minutes. So don't just make guess. Make sure to draw following those two rules and then pull, okay? So 2 minutes for this. Move tail of one near the tail of another one without changing the direction. Thirty more seconds. Tail to tail, and from tip of previous to the later. Previous to the later. Tip to tip. Previous to later. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay, let's see how did we do. Oh no. No matter what it is, quite a few of them are incorrect. So what I'm gonna do is I'm gonna send you to the breakout room and you guys figure that out among yourself and I'll redo the polling, okay? So maybe I'll send you for 2 minutes. Make sure to join, okay? How are you, Carl? Are you around?
Yeah, sorry, I was talking with my mic unmuted. I'm good. How are you?
I'm good.
That's good. That's good. That's good. Those are some really cool pictures that you took.
Yeah, I made them.
Are you gonna try to do any like any nighttime ones where you can like see like the star, like some, because I know you teach astronomy and things like that. That'd probably be cool to get some cool pictures.
Yeah, I like to do that, but somehow what happens is place for nighttime you have to be away, and I'm family man. I have to listen to everybody, right? I cannot
Right.
just say, "Oh, I'm gonna go away today for tonight." Right?
Right. They'll
And
all say
I
no, you're
cannot do
not.
it. I cannot do night photography, sky photography, or astrophotography near the city. I have to be out from the city.
Right, light pollution. Yeah, you have to get pretty far. That makes sense. That makes sense. But they're nice anyway. I know.
So seems like everybody is back. So what I'm gonna do? Oh. Sorry about that. Did not mean to put you in the room. Okay. I clicked the wrong button. Sorry about that, folks. I did not mean to send you back to the room, okay? I was closing it, but hit the wrong button. So I'm opening the poll for 30 seconds now. Oh, 5 more seconds. 5, 4, 3, 2, 1, and it stops. Let's see what happened here. There was little change, but not by very much, okay? Okay, we tried, right? Sometimes we need teacher. That's what it is telling us, I guess. Okay, so what do I do? Pause step, draw or move one, line them up tail to tail without changing the direction, okay? So for example, I can move this over there. So that means I can draw something like this. So this is now B2. It's the same vector. It has same length. It has same direction, but I just moved it from one place to another place, and I can do that, okay? So now I have B1 and B2. So now how do I draw the change? To draw change, we start from tip of previous to the tip of later, okay? So that's the change here, okay? So that means B is the correct answer, okay? So yes, it improved, but did not improve by much. Okay. So 2 steps, folks. So we're going to be learning 2 methods. So this is actually change means B2 minus B1. We are subtracting B1 from B2. So this is also an example of vector subtraction. And later we'll also learn how to add vectors. And addition method can be used to subtract as well, but one at a time. So this, I think, is easier to start with. So that's why I'm starting with this method, okay? And change in velocity over time is acceleration. So when object is accelerating, speeding up, we said, okay, what happens? The dot, separation of dot keeps increasing over the equal time interval. And then graph kind of curves upward. That's what we said, right? So what I did was I wrote a little program, BPython, okay, and captured when it was running. So let's watch this here. So this thing is moving and accelerating. How do I know? Because separation distance is increasing. Now this plot is curving upward, as you can see, okay? Oops. So yes, so it's, oops. I think it was the combination of 2. So here what's happening is 0 is at the middle. So initial position, negative 300 it says. So this is negative 300. This somewhere 0 here and positive 300. So even when it starts from negative, what happens? The nature of the graph looks same. And as you can see, what's happening? Separation distance keep on increasing, means it's accelerating, okay? So in this case, I just put number acceleration as 1. So this is positive acceleration. What's going to happen when there is negative acceleration? I'll show you a little later. Hopefully we'll meet to that point today, okay? So that's the motion diagram of accelerating objects, just like we saw on that video, right? Recording. Now, say the velocity is increasing. So if we were to make plot of not position versus time, not position versus time, I'm not talking about position versus time anymore. I'm talking about velocity versus time. So what's happening? This velocity, let's say if this is 2, maybe this is 4, this is 6. So how am I writing this number, increasing number? Because this length are getting bigger, bigger, and bigger, right? So this is 8, this is 10, something like this. So if the value of velocity is increasing like that every seconds, then I can plot out of those values, let's say. So I didn't put particularly a value. I'm just writing B1 for this value, could be any, okay? And B2, and making plot. And what do we see is that this plot looks like this. It goes a straight line. So why is that? Because change is kind of same all the time. So that means it has one slope. It being a straight line, slope is not changing. It has a fixed slope. And that slope is change in velocity over time because the rise over run. So rise here goes from here to here, means that's the change in velocity. B4 minus B2 in this case. And that's T2, T1 means delta T is T2 minus T1, or whatever way you like to write, okay? So that means change in velocity over time means acceleration. So that's how we define the acceleration. So rather than writing V4, B2, I'm just writing B minus B0, final minus initial, and same thing with the time, okay? So what I can do is I can rearrange this and write like this, okay? So T minus T0, you can just write T or delta T to make this bit neat, okay? And I think that's what I'm doing. What I'm doing is, what I did was I just moved this to this side and replace this by just T. So I'm assuming at the beginning T0 is 0, okay? I'm counting time starting from here, assuming that time is 0, T0 is 0 when I'm writing like that, okay? So you can think of this T as a time interval, which is started from 0, okay? So this relates the two velocities and acceleration. And remember, in this case, I'm talking about constant acceleration. Acceleration is not changing. Whatever value it is, it remains same. So for example, in this example, if I were to use these numbers, what you see, change in velocity between these is 10 minus 2, right? Final minus initial among these two, and divide by the time interval. And for the motion diagram, we use equal time interval. And let's say if that was 1 second, then this is gonna be, 10 minus 8, not 10 minus 2, sorry about that. So 2 over 1. So what is acceleration? 2. If I look at these two numbers, what do I find? Same thing, 8 minus 6 is 2, 2 divided by 1 is 2. So that's what constant acceleration means. Speed is increasing at constant rate every second. That's what constant acceleration means, okay? Constant acceleration does not mean constant velocity. Velocity is changing. Velocity could be increasing or could be decreasing. So whenever velocity is changing, there is acceleration. Other way around, whenever there is acceleration, velocity is changing. Keep that in mind. And we are looking at this special situation when acceleration is not changing. Acceleration is constant. Means velocity is changing with constant rate. So that's what we are talking about, okay? So this is second equation. We wrote the first equation last class, right? That related the position, velocity, and time. And this equation is relating velocities, acceleration, and time, okay? So So direction of acceleration is same as the direction of change in velocity vector. So for example, in this case, velocity is increasing. So if I were to draw V4 over here, what's going to happen? The initial in this case is going to be V4 because we are just looking at V4 and V2, V5. So it's going to be pointing that way. So velocity is pointing in the same direction as the, sorry, change in velocity is pointing in the same direction as the velocities or motion. So that's why velocity is increasing, and the direction of acceleration is same as the direction of motion. So other way around, when acceleration is in the same direction as the, as the motion is, the speed keeps on increasing, okay, or velocity keeps on increasing. So now here is question. In this time, you are asked to find what is the direction of acceleration. And direction of acceleration is same as direction of change in velocity. So do you know how to find change in velocity? Vf minus Vi, okay. Oh, my camera looks like gave up. So I let you pull on this. Make sure to draw it, okay? Make sure to draw it. So I'm giving you 2 minutes. Again, make sure to draw. While drawing it, don't change the direction of the vector. Okay, 30 more seconds. Bring tail of one to the tail of another one. And you draw a change vector starting from the tip of previous vector to the later vector, or initial vector to the final vector.
I'm sorry, could you say that one more time?
Oh man, its time is up. So you draw a change starting from tip of the previous vector to the later vector, or initial to final. Okay, I'm going to be closing this poll, folks, in 5 seconds. 5, 4, 3, 2, 1, and it stops. And what I just said, it was written in the slide. So if you have a copy of that, you can open that. I have posted them in Canvas. You can go back and forth and look, or if you have a printer handy around, if you like, you can print them, because I have made them small so that you can print all of them without wasting a lot of paper and ink. Okay, so here I see C, most of those, but there are quite a few of E as well. So let's see why this is correct answer, okay? So what we need to do is bring the tail and tail together without changing the direction means I can draw B1 from here. Okay, so that's going to be B1, this is going to be B2. Now, one is pointing in one direction, another one is pointing in another direction. So now what's the change? We draw a change starting from tip of the previous. B1 is previous, so tip of previous is here to the tip of later, or from the tip of initial to tip of final. So that's our change in velocity vector, which is C. Okay, so that's why that is the correct answer. So now they are pointing in opposite direction. They have same length. So it may seem like, okay, if this is 5 meters per second, this is 5 meters per second, right? Same length. They are pointing in opposite direction. If I am finding change, that means it may seem like, okay, change means final minus initial. So 5 minus 5 is 0, right? If we don't pay attention to the direction, that's the kind of math we'll do. But remember, math for vector and numbers, they are very different. So that's why this is not correct. Okay. So if this is positive 5, this is negative 5. Being vector pointing in opposite direction means if we assign positive for one, opposite gonna be negative, okay? One positive, another one negative. So now, if I were to write that, like let's say B2 minus B1, what happens? Let's say, which one is B2? I don't know, and doesn't matter. You can just choose one as a B2. For example, let's say even if I were to choose this as a B2, what's gonna happen? Negative 5, and there is negative sign here, and this is positive. Positive times negative is negative. So 5, 5. See, this gets added, becomes negative 10. What negative means? It means opposite direction to the positive. Okay, so that means the overall is pointing in that direction. That's all it means. Okay, and that's what's happening here. See, the length gets bigger. They gets added here. Although we are subtracting, but we are subtracting negative vector. So that's why it gets added. Okay, so let's keep that in mind. Do not just subtract the numbers. Pay attention and assign correct sign for the number. We are dealing with vectors, okay, which is different than scalar. So now here is another question of acceleration calculation. So you can draw and do the calculation, or you can assign the correct sign and do the calculation, okay? It's up to you. But I suggest you draw, okay? So now you have 2 minutes to answer this question as well. Thirty more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay. Let's see how did we do. Oh, almost split. So for this kind of problem, I already sent you to the breakout room. So I guess I will not send you. Let's do it together, okay? So what is the acceleration? So to find acceleration, we need to find change in velocity and divide that by time. Time interval for the change is 4 seconds. It's easy. What is change in velocity? Change in velocity means V final minus V initial, let's say. Or you can write V2 minus V1, or you can write V minus V0. Okay, so this is initial, this is final. So we need these. So which one is initial here? So motor scooter travels east. Oh, east. So we need to assign the direction. Yeah, did I miss something?
Nope.
Yeah, I think you said direction, right? Yes. So positive, let's say east, and let's say east is positive. Okay, east is positive, let's say. So that means BI is 12 meters per second, and it is positive. So if I were to draw it, since my east is this, so I can draw BI like this. So this is my BI. The driver then reverses direction and heads west. So now that means, oh, it's 16, even longer. BF. And if I were to write in terms of number, how do I write it? VF is what?
Negative 16.
That's right, negative 16 meters. Thank you. Yes, that's what that is. So I am drawing and I'm writing as well so that you can go either one method or another method, okay? And I'm showing you either way you'll get the same result. But also learn to draw and visualize so that in some cases, just by drawing, you will have idea how to do it, okay? So that's that. So now, using the drawing method, how do I do it? Delta V, to subtract one vector from another vector, I need to bring them tail to tail, or I need to draw them tail to tail. So I'm going to be drawing here. So BI goes this way, and BF goes that way. They are going in opposite direction. So because of that, what happens now? I need to, so that's the, once I line up tail to tail, that's the step one. Step number two, what do I do?
Divide it. Oh, I'm sorry.
But previous to tip later.
Yeah.
Previous to later, initial to final, isn't it? Did I draw it right? That's my delta V. So now, what's the length of this delta V? Length of this and length of that, isn't it? So that means it's 12 plus 16. That means delta V, length of delta V is 28. Is it positive or negative?
Negative.
Negative. Why is that?
Because you're going west, and we had already agreed that west was negative.
Yes, exactly. Yes, I like how you explained it. Okay, great. So that's 28, negative 28. So that means what is acceleration? So when I bring this negative 28 here and then 4 here, it gives me negative 7. So now, what is the meaning of negative here?
West. Yeah,
West.
west.
So that's why it is 7 to the west. Okay, not east, but west. So that's why D is the correct answer in this case. So this by drawing, you know, this we can do by drawing. Now let's say if I were not to draw it, I could still do it and get the correct answer. Let me show you that one as well. So delta V, so now I'm going here and using this equation. So BF, what is BF? Negative 16 meters per second, isn't it? Right? BF. And then negative BI. What is BI? Positive. So positive times negative is negative. So the sign, this sign not going to change. So this is going to be negative 12 meters per second now. So the total is negative 28 meters per second. So that way, that's the change, means the acceleration going to be negative 28 over 4 is 7. And again, this negative means west. Now, if I had assumed west as a positive, let's say, would the answer change? Let's say this is west and that is positive, let's say. How this all thing gonna change? Then that means the BI would be negative and BF would be positive, okay? And when I plug that in this formula, what happens? Now my BF is positive 16 and there is one negative sign in formula and another say negative sign in the number. So negative times negative becomes positive. So both of these are now positive and becomes positive 28. So the answer would be positive 7. Now, what is the meaning of positive now?
West.
West. West. Now, see, we started assuming west as a positive. So that means it's west. So physics not gonna change based on your assumption unless you make mistake. Physics remains same. Yes, sign flips here and there. Intermediate steps become slightly different, but the final answer has to be same. That's the meaning of physics. Physics remains same. Okay. Okay. Anybody likes to add anything on this one? Yeah, I know it is one, you know, it kind of counterintuitive to what we've been doing. Usually when we say change, when we say difference, we tend to subtract numbers, right? But these being vectors, it's slightly different. Yes, go ahead.
So for the original question we were asked, why isn't the answer a negative 7? Because didn't you do negative 28 meters per second divided by 4, and then you would get negative 7 meters per second squared?
That's right. Negative 7 meters per second square. And why wasn't that the correct? Why the answer wasn't negative? Can somebody, let's say, help me here?
Because it's to the west, and we decided that was negative.
Negative is the direction, not the symbol.
Right. In front of vector, negative means direction. That's right. And what negative direction mean when we said east was positive? Originally, we said east was positive, right? So that means negative means west. Opposite of positive is negative. Opposite direction of east is west. So that's why it has to be west. Okay. So it's not always Positive is yes. It's not always, it does not have to be that way. You can choose it, okay? You can choose it and be consistent, and you'll get the final answer, and it's not going to be different. It's going to be same no matter how you do it, okay? Okay, so maybe it's a good idea if you guys practice yourself, just randomly draw two vectors, put the numbers, and do the practice of finding change in acceleration, and just reverse the assumption and see if you get the same answer, okay? That way you can be sure you learn things. I'm not sure if a very similar question is on the worksheet or not at this moment, but there may be one, okay? So you wanna look at the worksheet and practice that. And if it is in the number form, the final answer, final number is there. And actually for the first worksheet, whole solution is there, but make sure you do it before you look at the solution. And there won't be solution for the other worksheets. Keep that in mind. It's for you to do. I did it for the first to show you as an example how you're supposed to do it, okay? Okay, so now we are talking about velocity versus time graph, not position versus, but the velocity versus time graph. And we learned that acceleration is change in velocity over time. So if it is velocity versus time graph, change in velocity means rise, and change in time means run, means it's a slope, okay? So with that information, I'll let you poll, and I'm giving you a minute to answer this question. Thirty more seconds. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay, so let's take a look. Okay, mostly B, but there are A and C as well. This is correct answer. So can somebody explain why acceleration is not 0 here, but negative?
I can explain.
Yes, please.
I got that it was negative because the slope of velocity is still going down. It hasn't leveled out. So your slope is still negative. And as we know, acceleration is the slope of velocity. So that's why it's negative.
Right, exactly. Thank you. So acceleration, when we are looking for acceleration from velocity versus time graph, we need to think in terms of slope, okay? If you choose this as a 0, you are looking at velocity. See, this is velocity plot, this is 0, okay? So you are looking at velocity, not acceleration if you chose that, okay? Thank you for very good explanation, okay? So let's move on. Now, we are making acceleration versus time graph. Yeah, did I hear some sound? Are you asking something? Maybe not, okay. Okay, so there is this velocity versus time graph. And you are asked to figure out what would be the appropriate acceleration versus time graph. So how you need to think? You need to think in terms of slope. Think about slope at many places here in this graph and think how, if you were to plot those numbers, how that gonna look like. Think in terms of that, okay? So now, for this, I'm giving you 2 minutes. Thirty more seconds. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay. Now, let's see what we got. Mostly D, but there are quite a few of A and C as well. Okay. So let's talk a little bit about it. So it starts from here, velocity starts from here and goes there, and it's a straight line. So whatever slope it is, it has a fixed slope. So let's say that is 5. Just a random number. You don't have to put number, but I'm doing that, okay? It is slope, and slope is acceleration. So it starts with non-zero number because slope is not 0 at the beginning, okay? So any answer that starts with 0, that cannot be correct. You find that, right? So beginning, yes, velocity starts from 0, but the slope of the line is not 0. See, the velocity 0 does not automatically mean acceleration is 0. No, okay? So it starts from 0, but it's increasing and constantly. And if that was 5, let's say, that's the slope. And then that's the acceleration. And now, after that, what happens? 0 slope. Okay. And up to here, 5, and up to there, 0. And from here to here is downhill, negative slope, right? And the slope looks a bit less steeper, let's say 4. It does not have to be, okay? And then again, it becomes flat here, 0. And by the way, this is negative, okay? This is negative. Sloping down, downhill means negative, okay? So now, what do we see? It starts from some positive value. This starts from positive value. This starts from positive value. And after that, what happens? Suddenly, it goes to 0. Here, what's happening? From positive, suddenly it's going to negative. Okay? instantly it's going 0. But sorry, here it's going negative. But here what happened? First went to 0. And that's what happening here. And then went to negative. Then went to negative. And then became 0 again. And became 0 again. So that's why D is the correct answer. Okay. So did I choose the answer here? I did not. So anybody likes to add anything, something on this? It's your time.
Would letter C be an example of like a velocity graph?
A velocity graph is this, right there. Right? So maybe how would the velocity graph gonna look like when we have acceleration like this? That could be another good question, isn't it? Right? So going from acceleration to velocity, how do we do it? Let's try that, okay? Maybe I will not ask you, but let's try that. Let's see what happens. Since you were curious about velocity, let's look at this. So this graph is just like, you know, like what's happening here. Acceleration is increasing. Oh, that's tough to draw. So what happens? Acceleration starts from 0.
Is it a parabola, kind of?
Yeah, yes. Acceleration is increasing and positive. So we could start from anywhere. We don't know. It says just the acceleration starts from 0. So that could be velocity, could be 0 at the beginning or positive or negative. We don't know for sure, okay? But what we know is it's a parabola like that, okay, up to that point. And then what happens? Acceleration goes suddenly to the 0. Okay, it goes suddenly 0 and remains 0. So that means now it has to be straight line. Slope of this line is 0, isn't it? And then acceleration is negative suddenly. So that means it has to slope down, negative but decreasing. Okay, acceleration is not increasing but decreasing. So when it was increasing, it was like this. So when it's decreasing, it goes like that, okay? So what happens? It has to be sloping down and it's gonna be a little tough. So we have to have something like this. And then becomes 0 means after that, it goes flat again, okay? And so, yeah, you may wanna bring that one there. And I think there are a couple of nice exercise on our worksheet, okay? So please, you know, go and do those, okay? Do not look at the solution first though. Otherwise, it's gonna be like just a reading and you don't learn physics by reading solutions. You have to do it. Believe me, you have to do it. So now, here is another question where there is velocity versus time graph. But now, rather than asking you to draw acceleration graph, it says what's happening, okay? So there are series of questions, situation is kind of same, okay? So for this, I'm gonna give you, let's say 1 minute and 30 seconds, but for the others, you'll get just 1 minute. So velocity versus time graph is there, okay? I see velocity is on the, so this is positive side, and this means that's the negative side. That's what I see here, okay? So now let me open the poll, and you have 1 minute and 30 seconds to answer this. 30 more seconds. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay, let's see what we got. So D, E, and A, so quite a few of them. I think it's a break time. So let's take a break, okay? Let's take a break for 5 minutes.
Hey, Professor,
Yes,
I have a doctor's appointment. I have to leave right now.
okay.
Is
Stay,
it-
stay safe.
okay, thanks. Well, I answered the last question. How many more questions are there?
I don't know exactly.
Uh,
Okay, maybe 3 or 4 questions. Not that many, I guess.
okay, I sent you an email. You know, I asked you if you could if there were still more questions, if you could email them to me and I could answer them that way or something.
Oh, unfortunately, I don't know. It's gonna work that way. Okay, but these questions
Okay.
are on the posted slide. You can find them on the Canvas, but unfortunately, you cannot pull from, I guess, wherever you are.
Okay. All right. Well, thanks anyway.
Okay.
See you later.
Okay.
Dr. Tungana, for your office hours, where do we attend? Like, do you have a Zoom link?
Yeah, it's this link,
Oh, it's the same link. Okay.
right?
And then we can check our
So
homework.
today, I think it's I have office hour after the class, right?
Yeah, from 4 to 4:30.
Right.
And we can check our answers then, correct? For our worksheet.
Yes, you can talk to me with that. Yes.
Okay, thank you.
Yeah.
Welcome back. Please feel free to meet my lovely wife Rose, in the background. Yep.
Oh, let's see.
Hi, Rose.
Hi, Rose.
Hello.
Welcome.
Hello.
They're all saying hi to you.
Hello.
Oh,
I got like 6.
oh, that's so cute. How many people are in the class?
Like 90 people.
Wow.
96, yeah.
Or 100.
Something like that.
Is this the one where they said you sound like a radio personality?
I
Okay.
think so, maybe.
So is it any picture that you want, or is it just pictures of Colorado?
Oh, any picture you took is fine.
And how recent?
Doesn't matter. So are you sharing now?
Well, I was looking for a good one to post.
Okay, maybe after the class then, okay?
Yeah.
Let's get to the class now. Okay, so for this one, I wanted to send you guys to the breakout room, okay? This is a bit new type of question, and I'm hoping it's gonna improve after you. So right now, this is the standing, okay? So that's why I didn't tell you the answer before. So make sure to join breakout room when you get invite. Oh. Oops. Did I add the room here? Okay, so I'm opening the room. Please join.
Somebody in my group was explaining it to somebody else, and then we got back to the break.
That's okay. I got the message.
Okay, okay. Did you re-pull the question, Doctor?
I haven't.
Okay.
Okay, I'm guessing everybody is out now. Okay. So let me open this and there will be 30 seconds for this, okay? 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay, let's see what happened. So now mostly D and some E. Okay, so looks like we need teacher here. So I'm here. Okay, so let's look at graph. Okay, so what's happening here? It starts from negative velocity, and velocity is decreasing, isn't it? So if, let's say, if this was -5, this is -4, and so on, it is almost reaching to the 0, right? So what that means, velocity 0 means it's almost stopping. Velocity is decreasing means it's slowing down. Now, the slope is positive and constant. That means acceleration is positive, and here it says positive is right. So acceleration is to the right, but velocity is negative, means this thing is moving negative. So velocity and acceleration, they are in opposite direction. And that's why it is slowing down. Makes sense. Does it to you?
Yes.
So how did I know velocity and acceleration are in opposite direction? Because velocity is all over. This is negative, right? But slope of this line is positive. So slope is the acceleration. And positive means to the right, and negative means to the left. So now let's take a look what these options are saying. The car is moving to the right at constant velocity. If it was moving to the right, right means positive, means velocity would be positive, and if it was constant, this would be like this. Do you see that? Okay. Constant, positive. Positive means on this side of the graph. Constant means slope is not changing. So that's why this is not correct. The car is moving to the left. Moving to the left. Negative velocity, left. That's good. But it says at constant velocity, means it has to be flat. It's not. So that's why this is not correct. Constant velocity means no acceleration. But we see there is acceleration because there is slope of this line, non-zero slope. Car is reversing direction. So if it was going other way around, then yes, it's going from negative velocity, means going left, slowing down, and then turning to the positive, okay, like that. It's not crossing that line, means velocity remains negative, means it hasn't changed the direction, okay? So that's why that is not correct either. So now, the car is moving to the right. It's not. So that's why that is not correct. It's moving to the left. Why? Velocity is always negative. It may look like it's moving to the right, but remember, this is velocity. It's not, we're not plotting position here. We are plotting velocity. It simply tells us whether the velocity is negative or positive, whether it's bigger or smaller. That's what it says, okay? So right or left, in terms of position, we need to know that based on, oh, if velocity is positive, that means it's moving to the, let's say, right direction, okay? But since the velocity is all over, it's negative, never was positive, that means you cannot say it's moving to the right. It's moving to the left. Why? Because velocity is negative. And acceleration is constant because slope is constant. And positive slope, let me add on that, okay? So looks like last option is correct here.
So Professor, if it was to start at 1, then it would be moving right, but because it's in the negatives, it's moving left.
If it was moving right and the velocity was positive, then the graph would look something like this.
Okay, yeah.
One of those line, any one of those line, okay? But this is on the negative side, and negative side means left. Okay, so yes.
So if that line crossed the 0 line, would that make it a positive motion to the right?
That means now it's moving to the right. It's reversed.
Okay.
Think about this. Okay, let's see if I can show you here. So this is a rod and I have a car. What is exactly happening based on this graph? First, let's see the negative side, and B is large at the beginning, isn't it? So what's happening is it's moving, let's say, which side is left? Which side? Is this left or right for you?
That's right for me.
That's right.
That's right?
Yeah.
Okay, then let's move left then this way. So it was moving, right? And moving to the left. But it was moving faster first, faster and slowing down. And see, the velocity becomes 0. Do you see that instantly? It reaches to that horizontal line. Horizontal line means 0 velocity. So what happens? It's moving fast, slows down, stops very briefly. And then it starts moving
And then
opposite.
Yeah.
You see that? If the red line was there, but we don't have red line, means it is slowing down, it's still slowing down. Since it hasn't touched the line, it hasn't stopped yet. And rate of slowing down is constant. So if it was 10 at the beginning and then 8, that means 6, that means 4, and so on happening, okay? So that's what it means. Yeah, that was nice addition on whatever we are doing, okay? Anybody likes to share any thought?
Yeah, I kind of have like a, so I was a bit confused and I think I figured it out, but I want to just make sure that I'm thinking about this right. So we're not treating this velocity time graph like it's a position time because I was thinking if the velocity, it would be position is negative, that means it's going to the left, but this is because velocity is a vector, so it has a direction. And so the negative isn't a magnitude, it's a direction.
Yes.
Okay.
That's right.
Okay, cool. Thank you.
Yes. Okay, good. So anybody else? Yeah, it is difficult to grasp, but remember what we are trying to do here. We are trying to translate motion into graph. In this particular question, we are trying to translate graph into motion, okay? And another skill we are learning is to translate motion into equation. So think about big picture here. So can you do that? If you can, yes, you are making progress, you learned, okay? If you are still confused, so yes, maybe you are still making progress, but you need to work more, okay? So we need to be able to go from description to the graph to the equation, or go all the way around and so on. That's what we are trying to do here. But all cases, we are looking at the constant acceleration. And constant acceleration also means zero acceleration. Zero acceleration means no acceleration. That means constant velocity. So constant acceleration also covers the part where velocity is constant. Okay?
And I would just real quick to plug, if you're confused, please come to SI. I know everyone that went to SI Monday and Tuesday probably understood everything that went on. So please, if you're confused, come to SI.
Okay, good to know that, Crawl. And yes, please, yes, we need help when we are in learning phase. When we first try to ride bicycle, somebody had to hold that bicycle for us, remember. And you did not just hop in the bicycle and you started riding, okay? You may fail, you may have fallen, something like that, okay? So let's keep that in mind. So learning physics is also kind of learning bicycle. You need to practice. Practice with thinking, okay? So more thing has to be moving in that case, in this case. In bicycle, you just need to move. Let's say pedal and hand a little bit, okay? But here moving parts are a lot more than that. So what that means? That means needs more practice. Okay, so now if we have velocity versus time graph, we can find position. Why? Because we know there is a relationship between average velocity, change in position, that's what the displacement is, and time. So now let's suppose we want to find displacement from velocity versus time graph. So how do we do it? Okay, so what do we find is displacement is product of velocity and time. So whenever we have product of those two things, and if we are plotting those two things, for example, velocity versus time graph we are talking about, right? What we do is, let's see, when we learn to make graph, probably we remember we plotting y and x, is that correct? Now, if I have a plot, let's say something like this, simple. Then what happens here? This is y, let's say y is one side length and x is another side length. If I look for the area of this under this plot, so when we say area under plot, we go all the way to the horizontal axis, keep that in mind. So in this case, what is area? How do we find area if this y length and this is x length? How do we find it? We multiply it, right?
X times y, yep.
Right. Okay. Now, here what we see is, you are given y times x. And you are being asked, what does it mean, product? What product means? Then what would you say? It's an area, right? Now, here, what you have is, instead of y, you have b. And instead of x, what you have is t, okay? So now, what is the product of b and t? Product of b and t is displacement. And product of b and t in b line and t line in this graph is area. So that means product of b and t is displacement, and product of b and t in a graph is area. So that means displacement is same as area under that plot. Okay, so that's the important thing you want to remember, and hopefully you understood why that's the case. Okay, now here, what is the displacement from 8 to 12 seconds? 8 seconds, what is that? So time is in horizontal axis. 8 seconds means here I'm looking at, and to 12 seconds means here I'm looking at. Okay. So now it says displacement. Sorry, what is the displacement? And that is the area under the plot. So here, yes, this is whole plot, but we are interested in only this part of the plot. So area means you have to go all the way down here, not just there, okay? Line is stopped there doesn't mean you just find the area there. What you do is you go all the way down, okay? So in this case, you look at this plus that, both of them, okay? So now you find the area. Means you find the area of rectangle and find the area of triangle and add them together. So that's what I'm going to be doing, okay? Area of rectangle and area of triangle. Oops. So what is area of rectangle here? This length is 4, isn't it? And how about this length? Oh, looks like that is also 4. So that means it's a 16. How about length of this triangle? So this side is 4. How about this? 12 minus 4 means 8, right? And do we know how to find area of triangle from the sides of the triangle?
Yeah, it's the length times the width divided by 2.
Right, half of base times height. That's right. Okay, so 16 plus 16 is 32, and it is meter. And all the area is positive here, so it is just moving in same direction. See, the velocity is positive. Velocity is still positive. What's happening is just slowing down, that's it. Okay, still moving in the positive direction of choice. It hasn't changed the direction in this segment. It's just slowing down, that's it, okay? Slowing constantly at constant rate. Now this question is from worksheet, okay? Exactly same. So what was the average speed in past 8 seconds? Past 8 seconds means you start from 0 and go to 8. So what is the average speed? So we want to find average speed. How do we do that? This is velocity, right? And this is time. What is average speed? V average, V is displacement over time. Do you guys still remember that? Okay, so that means we need displacement. How do we find displacement? Find the area under the curve. Maybe if I do that, it's going to be easier. Find this area, this area, this area, add them together. That's going to be displacement. And divide that by time interval, which is 8 seconds. Did somebody already find the area?
Is it 28?
Did I do it right?
Yes.
Okay, so how much is total then? 32 over 8 seconds, is that correct?
Should be 28.
Total would be 28, not 32. Oh yeah, 12 and 16, 28. Yeah, huh. I forgot how to add. Okay. So see how it works out unit wise as well. Let's see. delta x is meter, so meter over second is meter per second. Okay, so that's the average speed. Now it says, what was the average acceleration? How do you find average acceleration? It is change in velocity over time, isn't it? So how do we do that? I want to go from 0 to 8. So what I do is I can just, so that means it's just change means final minus initial. So I can just use this 6 and 0 and that. So that means it's a change in velocity is 6 and change in time is 8. So 6 over 8. You can see that. Or you can just draw a straight line for the average, okay, and find the slope of that, okay. Either way, you should get the same answer. An answer should be 6 over 8. So that's how we can use velocity versus time graph to get displacement and other things as well, okay. So we did that numerically, but if we were to, rather than assigning actual number, if we were to assign some initial velocity, final velocity, and then initial time and final time, and where to find area under the curve, that means area of rectangle. You see that? Area of this rectangle. So how much is that? This final number minus initial number, which is 0, means b 0x minus 0. That's that. And time interval is t minus t0. So rather than using number, I'm just using variables now. And this is half times height times base, okay? So if I were to do that, then what happens? I can basically simplify this, and simplifying gonna be easier if I were to choose t0 as 0, or just write that as a delta t, okay? So I'm doing exact same thing, but now I'm using variables because I want to write formula, okay? I want to write formula, and I want to make use of this formula we just, few slides ago, I think before break, when we were defining acceleration from the slope, we did, okay? If I plug that, so it's going to be a little bit algebra. So you plug that and solve that, you get this equation. So if you can do this algebraically, if you can follow, that's great. If you cannot, that's fine too. But now remember, we have now 2 more equations, this and that, okay? So all these makes the kinematic equation. So we can use this equation to solve problems when there is constant acceleration. If acceleration is changing, we have to do something else. But as long as acceleration is constant, we can use, see how we went from graph to equation? See, that's what I was talking about. So now, how do we use those equations? So first, what we need to do is we need to figure out what do we know, what are given in the question. And once we figure that out, we list them, okay? List what's known. Remember, all these equations, although we wrote 4 main, these are 3 equations, okay? And so all these equations have 4 unknowns. 4 quantities, they are related to each other. 1, 2, 3, 4. This x minus x0 is just fancy way of writing delta x. So I'm counting that as a 1, okay? 1, 2, 3, and 4. 1, 2, 3, and again 4. So basically this equation came from this equation by substituting this. So if you understand Basically, these are just two main equations. This came from these two, means even without this, we should be able to solve problem. But we are sticking with this, and you can use this equation when you don't know the time, okay? So now to solve this problem, what you need to know is what are the things that's given. If 3 out of 4 are given, you can find fourth one in one step. But if you don't know 2 out of 4, then you need 2 equations. Okay? That's algebra I'm talking about, not physics. Okay? So now, I want you to look at this question, note down what do you know, and based on that, which equation gonna be helpful for you to solve this problem. Decide that. So this is the first step on actually solving problem. Once we know the correct equation, you can plug in those numbers you identified and you can solve for it, okay? So I'm giving you 2 minutes for this. Thirty more seconds. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay, so let's see what did we get here. Variety is here. Interesting. I don't have much time to put you guys on the breakout room. So what I'm gonna do is I'm gonna talk about it. So first step, list the thing you know, okay? So it says it accelerates, the player accelerates the puck from a velocity of this to this. So what are these numbers here? Are those acceleration or velocities?
Those are velocities.
Right. So initial velocity is 8 meters per second. And final velocity, based on this notation, we are just writing bx, 40 meters per second, right? So now it says in the same direction, if this shot takes that many seconds, so that means that's a time interval. Looks like time interval, we are just writing t here. Calculate the distance over which the puck accelerates. So what do we want? Distance. And since this is going in same direction, distance and displacement gonna be same. So see, 3 things are known, and we want this one. So which equation have these four quantities. Let's see. Bx, B0x, time, but this has acceleration. So we don't know acceleration and we are not looking for acceleration. So maybe this is not a good idea. This is delta x, okay? And that's what we want. B0x, yes. Time, yes. Acceleration, oops, no. Here, we need acceleration as well. Yes, this is delta x. These two things we know, but we need acceleration. So it seems we cannot solve this problem in one step. What we need to do, we need to first find acceleration by using this equation. And once we have that, we can use either this or that to solve this problem. So that means that has to be the correct answer in this case, okay? So that's how we use equations. So many of you thought, okay, B is the correct answer. Yes, that's what it looks like. There is delta x, good, but we don't have acceleration. That was the problem, okay? So now let's talk a little bit about from horizontal to a little bit inclined. So if you push something uphill, what happens? It slows down, isn't it? So that means if you are looking at how far it went in 1 second, and another second how far it went, you'll see it travels less and less distance. It's slowing down, okay? You just pushed it and let it go. You're not continuously pushing it. It's like you reach to the bottom of the hill there and you are trying to go uphill. Now let's suppose your car is moving at 40 miles per hour and then you don't hit the gas pedal. What happens? Car just slows down. And that's what's happening here, okay? So now in this, so there are series of questions. I wanted to lead you to the answer, but let me go through this. So what happens here? Velocity is decreasing, isn't it? So what is the direction of change in velocity? When it's decreasing, change is in the opposite direction, and we learned that, how to do that, right? So B0 and B1, I can draw tail to tail, right? And then what happens? This V0 is this. So I need to go from tip of this to that. So that's why that's the delta V, okay? So when it's decreasing, change is gonna be in opposite direction. Now, what is the direction of acceleration? Direction of acceleration is same as the direction of change in velocity, means the acceleration is downhill. It's going uphill. See, motion is uphill, but acceleration is downhill. They are in opposite directions. That's why it's slowing down, okay? Is there acceleration where it is turning back? So it goes there, and then what happens is it starts coming back down. So velocity was in this direction, and velocity goes in that direction. So there is change in velocity. If we were to find change by drawing it, then what's going to happen? This is going to be the initial, let's say BI for that change, okay? And this is going to be final. Means I have to start drawing from here and go that. So delta V, see, there is acceleration and it's pointing down. So velocity is 0 instantly, but that does not mean acceleration is 0. To find acceleration, we need change in velocity, not velocity, but change in velocity. Another time, if you go a little past that 0 velocity time, then there is velocity. So when you take account of that new velocity and 0 velocity, the difference is the change, and difference is not 0. Okay, so that means there is acceleration, okay, even when it's turning. And when it's coming down, now it's speeding up. So speeding up means the velocity and acceleration, they are in same direction. So whether it's going up or coming down, acceleration is downhill. That's what we learn. So to convince yourself, go through this question, draw, okay, and find delta V from the drawing by drawing, okay, and convince yourself just in case if it's not clear, okay. So I want you to do that. And now that was inclined. This last rod, is it visible? My phone may be visible, okay. So it was inclined. So now what we do is we go extreme, vertical, totally vertical. So it's the same thing. It's the same thing, okay? Just we went straight up. It's the same thing. So that means just like we saw in the previous case, acceleration was down all the time. If you were to draw it, you'll see acceleration is down all the time. So that's why when I throw this ball and it's going up, acceleration is down. It's coming down, acceleration is down. It's at the maximum height, acceleration is down, not zero. So that's how it works. And I want you to convince yourself by drawing all those. And for the maximum height, use this as an initial and this as a final and draw it, okay? And for example, for going up, use, let's say, these two. For coming down, let's say, use these two, okay? And draw that. And if we were to make plot, how it's gonna look like? I'm showing you, I'm going from motion diagram to plot, okay? So see, it's slowing down means curving down, as you can see, okay? And maximum height, flat slope, I'm plotting position versus time, okay? And now if I were to plot velocity versus time graph, how the velocity versus time graph gonna look like? It's that, okay? And it turns out the slope is 9.8. And since we are choosing up as a positive, the slope is negative, means acceleration is downward. That's all it means, okay, folks? Sorry, I took a couple minutes more than scheduled time. So I'm leaving it here. So expect to get some kinematic equation problem solving types of problem and this kind of thingy. And by the way, this problem, you can still use kinematic equation. Now for this, acceleration gonna be known, okay? Acceleration gonna be known for the up and down motion. That's what we call free fall, okay? So I have office hour, so I'm sticking around. If you guys want to stick around and ask questions, feel free to do that. Oh, by the way, I think I have office hour Monday at 11. I'm moving that to Tuesday, and I'll email you guys about it, okay? I'll be moving that to Tuesday noon sometime. And that Monday office hour is not working for me. I have another duty to do that, okay? Okay, have a good weekend.
I'm sorry, I literally left as you said, by the way. What did you say?
Oh, I'm gonna be changing my office hour. That's on Monday.
Okay, thank you, sorry.
And moving that to the Tuesday.
Mr. Carl, you there?
Yes, I'm here.
All right, fantastic. The link you just posted, I can't follow it.
Okay, well,
It worked for me.
It did work for you? That's okay. All right. I just
and also keep in mind that that is not the only place. If you've been paying attention to your emails and the announcements on Canvas, all that info is there. So
yeah.
if you can't follow that link, just hop on the announcements. Info's there. You can hop on Learning Resources Center. There's a lot of ways to get there, brother. You don't have to just follow that link, but I posted that link just in case. Most of you should be able to follow it, but this is just repeat information that you've been given before.
Thank you.
Thank you.
Hey guys, have a good night.
So I gotta tell you, I don't know why I am so confused with the vectors and the arrows. I understood it on Monday, the back-to-back, And then for some reason today, I found myself completely confused. And I don't know what's throwing me off.
Yeah, I'm having the same confusion too.
So if we were to go back to the explanation from our first think and answer, that was what, slide 16 from the PowerPoint. I guess I just didn't understand when I put the two arrows, because they look like they're the same length, and when I put them tip to tip, and this is just
You mean
probably
tail to
me being
tail?
too literal. I'm sorry.
You mean tail to tail?
Yes, sorry, tail to tail. I was confused
By the
as
way,
to.
you know,
go ahead.
can I stop you for a second? Looks like my slide is frozen, so I cannot go back. So I have to, you know, somehow get rid of that. So I'll be back with you pretty soon. I'm gonna be stop sharing for now. Okay.
Okay, I'll wait.
Yes, I'll go there. Okay.
Thank
I'll
you.
be on Zoom, but let's see. For a moment, looks like I don't know. I may have to get out from the Zoom. Oh, here. Looks like it's gonna work. Okay. Now. Let's see. Your slide number and my slide number are the same or different. So is it from last week? Sorry, last class or this class?
This class.
Today's
It's
class.
Yeah, it's the very first reef question that we had.
Okay.
I just looked at your PowerPoint
Is this
slides.
one? And let me get rid of this clicker thingy as well, since we're not going to be using that, right? So that way, more room here. Okay. And now, oh, I haven't shared you, and I'm asking that question. Oh, sorry about that.